Okay, let's play around with some volume here. I've got a tent, for all intents and purposes, a tent there. It is definitely a prism because we've got two shapes that are the same. That's the two triangles on either end, so it's clearly a triangular-based prism. We only have one rule for the volume of a prism. That's the area of the base times the height of the prism. Here, the base is a triangle, so it's base times height on 2 times the height of the prism. And we want the base and the height of the triangle, so the base is 9. The height, the perpendicular height, is this 8 on 2. And the height of the prism is the length of the prism, which is 10. 9 8 is 72. 72 divided by 2 is 36 times 10 is 360, and whatever units they are, they're cubed because it's talking about a volume. So always area of the base times the height, work out what your base is, and multiply and find the area of that base and multiply it by the height. Let's do something a little more funner. Let's do a pipe. Bit dodgy drawing, but I think you see that it's some sort of cement pipe or hose or something like that, and we're finding the volume of the rubber or the cement that's making the pipe. Now I'm going to say there's two ways we can do that. Let's divide this page into 2. And I'm going to squeeze it in there a little bit, so setting out won't be fantastic, but let's just go with the traditional volume equals the area of the base times the height. So the base here is this annulus, which we did in that last video. So using pi r squared, put that somewhere on your page so you can read it. Area of the base. Let's put some measurements on this. Let's just say, shall we go 5 and 4 again? So the big one's 5 and the inside's 4. So the area of the big is going to be pi times 5 squared times pi times 4 squared. So that's the area of the base, which is the annulus. I'm going to multiply it by its height. Should we stick with 10 again just to make it easy? Clearly in the exam you've got a calculator, so it doesn't really matter what the numbers are. Okay, we've got here 5 5s are 25 pi. That's our minus. How did that times get in there? Minus 16 pi times 10. You'll remember that 9 pi is what we got in that last video for the area of that annulus. So we've got 90 pi as the volume, so it's units cubed, is the volume of the cement that's making that big pipe, or the volume of the rubber, or whatever you like. Okay, so that's one way to think about it. Alternatively, we can say that there are two volumes here. There is a, where's my colour? There is an outside blue volume, and then let's take out or subtract the air that's in the middle of it. So you can see I've got a blue cylinder and a green cylinder. The blue is big and the green is small. So I'm going to say the volume of the rubber would be the volume of the big minus the volume of the small. Different way of thinking about it. Okay, big, let's go. Area of the base times the height. And we're going to use pi r squared. So I'm going to go pi times 5 squared times 10. That's the volume of the big, which is area of the base times the height, minus 4 is the radius of the small green circle. So 5 5s are 25, so it's 25 pi times 10 is 250 pi. 4 4s is 1660. And 250 pi minus 160 pi is 90 pi, and it's u cubed, or units cubed. So that's some ways of thinking about finding the volume where the volume is quite a complex situation.